Hello. This video is going to just do a brief overview of how we're going to enter data to create a scatter plot in Desmos and write our line of best fit. So the first thing that we're going to do is we need to create our table of values. So normally the table of values is provided. Right now I'm just going to make up some numbers. So to do that, to create the table, I'm going to hit the plus sign on the left side and it's going to ask what I want to import. And I want to import a table. And so I'm just going to create some numbers here. So 1, I'm going to tap down, 2, 3, we'll go 5, 8, because again, data is not perfect, 10, 6, 5, 4, and 3.2. Okay, now when you notice, as I'm typing this, my data is popping up on the scatter plot, and by using the pinching feature on our iPad, you can zoom in or zoom out. Now, when I look at this data, it could be linear, and so let's practice writing an equation of a line of best fit. So to do that, I am going to tap in the box 2, and we're going to tell it where we want our data from. So to start, we want a line of best fit, so we're going to use y equals mx plus b. So I'm going to press y, and I'm going to type y1 because it means it's going to pull from the y1 values. And instead of writing an equal sign, what we're going to do is we're going to hit the ABC button in the bottom left, and we're going to use the approximate sign. And we want the little tilde. That indicates we're going to be using our line of best fit. And so now we're going to type mx1 plus, I need my b, okay, and here we get our line of best fit. So if I was writing my line of best fit, we're going to use the m value, which is negative 0.8. So we have negative we'll round up to 80. My y value b is 8.67. And we're always going to use the r value, which describes the correlation, which would be strong negative correlation here. Again, as we create that for line 2, it automatically draws in our line of best fit for us. Okay, so that's a short video just explaining how to enter data from x1, y1 and type in our line of best fit. Hello, welcome to day 7. So these notes are going to walk us through how to describe and interpret data using linear regression. So linear regression is a measure to help us understand to what extent there's a linear relationship between two variables. And it's the exact calculation of the most accurate line of best fit. So previously we estimated the line of best fit, and now we have the exact calculation, and students are going to use either their graphing calculator or Desmos. This video is going to walk us through how to use a graphing calculator for linear regression. And once we have our equation, we're going to do two things with it. It's going to help us describe the trend of the data and interpret the data. So to describe the trend of the data, we're going to do two things. We're going to look at the scatter plot, which we'll watch a short video on how to do that on your graphing calculator, and we're going to use the correlation coefficient R, which is going to help us describe the correlation. And our calculator is going to give us an exact R value. It's going to be between -1 and 1. Okay? And so when we interpret it, we're going to use the following guidelines. So if it falls between -0.8 and +0.8, so we're going to make this -0.8. Okay, if it's in the middle, it's 0, there's no correlation. So anything between 0 and +0.8, we would describe it as weak positive correlation, versus 0 to -0.8, again, we would use the word weak, but it's going to be a negative correlation. Okay, and then anything between 0.8 and 1, or -0.8 and -1, is when we're going to switch over to a strong positive correlation, meaning there's a positive slope, or a strong negative. And this explains to what extent our data is linear. Okay? The other thing we're going to do is we're going to interpret data. So to interpret data, we're going to use our line of best fit, which again, we're going to show you how to do it. And we're going to make predictions by using interpolation, which is predicting data inside the given data set, or extrapolation, which is the term we use for predicting data outside of the given data set. Okay? And so here we have an example which is going to help us practice describing and interpreting data. So the table below shows the total sales from women's clothing stores in the United States from 1997 to 2002. Make a scatter plot of the data and describe the correlation of the data. So the first thing we're going to do is we're going to adjust our years. So whenever we give you a year, we're going to cross this off and make it year 0. 1998 is going to be year 1. And this helps us because when we get our y-intercept value, we're not going to have a y-intercept value of year 0. It's way more accurate if we adjust these numbers starting at 0. Okay, and year is going to be our x, sale is going to be our y. X is the same thing when we enter our data. We're going to enter it into L1. Y, we're going to enter it into L2. Okay, so to enter our data, I'm going to first create my table of values. And so we have our years, adjusted years of 0, 1, 2, 3, 4, and 5. And then my Y1 is 27.9. Okay, so notice these values are not on my graph. However, if I zoom in, I will now see the purple dots, the 6 pieces of data from example 1 about the total sales from women's clothing stores. I look at this graph, it looks pretty linear, and so that tells me that our scatter plot tells me that we can use linear regression. And so to get our linear regression, again, we're going to type Y1. Remember, the key now is to use the approximate sign. And then we want M, X1, because again, we're pulling from the X1 values, plus B. And here we get our line of best fit. So our slope is 1.36 when we round to the nearest hundredth. Our y-intercept is 27.72, and our R value is 0.99. So now that we have our linear regression equation, we now can interpret and write our line of best fit. So we said A was 1.36, so our line of best fit is y equals, again, A is our slope, so 1.36x plus our y-intercept of 27.72. Okay, again, remember our B value comes from the B value output, my y-intercept, and my slope, also known as A in linear regression, is our A value. Okay, again, slope, y-intercept. Okay, we will never use the r squared value in Algebra 1. We are going to focus on the r value. So again, r equals, when I round correctly, 0.99. So if I go up to the chart at the top, 0.99 is like right here where I just marked in red. And so that indicates it's really close to 1, which tells us it's a strong positive correlation, which means my data is almost perfectly linear. It's not exactly, but it's almost there. So when we interpret this, we would then say it's a strong positive correlation. Okay. So again, this walks through the video. The video walks through how to enter data, adjust your stat plot, make a scatter plot to ensure it's linear, and then perform regression to ensure that we get our line of best fit. Again, linear regression gives us our exact line of best fit. We do not have to estimate anymore. Okay. So, example 1 says make a scatter plot of the data on your calculator. And notice we have this data of tall buildings in the United States. So we have different buildings, Sears Tower, Chicago. Obviously, we know it's now called the Willis Tower. And we have stories and the height in meters. So we're always going to make the first variable we see. If it doesn't tell us X and Y, we're going to make this L1 and L2. So what I want you to do, and you have to get comfortable doing this, is I want you to enter this data in L1 and L2 on your calculator, okay, and run linear regression. So what we're going to do, you can make a scatter plot. You can check it if you want to make sure it's linear. And then step B, using your calculator, I want you to find the line of best fit. So unpause the video when you are ready to check your answers. Please try this on your own. Okay, so when we ran this data, we should get y equals 2.59x plus 124.74 as our line of best fit. The R value is 0.88. The second step is we're always going to interpret it. The first part is it's strong or weak. So 0.88, again, I'm going to scroll over here. 0.88 is over still in the green section. And so that tells me I'm going to choose strong. And it's a positive number. So we have strong, positive correlation. Now the next part is, now that we have our line of best fit, how does it help us? And again, this helps us make predictions. And so what we're going to do is we're going to predict the height of a building that has 80 stories. So 80 stories is my X. Again, over here, stories is X. Okay. And we're going to make a prediction what the height would be using the line of best fit. So you cannot use the table of values. Now that we have a line of best fit, we're going to say y equals 2.59. Instead of x, I'm going to replace it with an 80. And when I calculate that, I get 331.94 meters. Okay. So we predict using our line of best fit, 80 stories, an 80-story building is 331.94 meters. Okay. Now, when we make this prediction, we can then classify it either as interpolation or extrapolation, and that's looking at our given data set. So over here in the given data set, I see that my minimum is 55 and my maximum X value is 110. And so does 80 fall within 55 and 110? The answer is yes. So this is an example of interpolation because I'm predicting a value that falls within the given data set. Okay, so what I want you to do is I want you to pause the video and I want you to try to calculate part A, finding an equation that models the student's GPA as a function of hours of TV watched. So the table shows the number of hours of TV a week 10 students watched and their GPA. So again, hours of TV watched and our GPA. L1 is going to be our top value, also known as our X, our input. L2 is going to be my output, which is Y. And I want you to try, pause the video, and find the line of best fit. Okay. So using linear regression, you should have been able to write your line of best fit, which is y equals negative 0.05x plus 3.84, and identify the correlation coefficient of negative 0.63, which tells us we have a weak negative correlation. So C and D we're going to work through. So examples, or part C says, using your equation, predict the GPA if a student watches 17 hours of TV. So remember, once we have our line of best fit right here, we have to use it to make predictions. And so 17 hours of TV means when x equals 17. So if I say y equals, again, I'm using the line of best fit, I get an output of 2.99. So again, I'm using the line of best fit to say, oh, what happens if I watch 17 hours? Oh, then your predicted GPA is 2.99. Now, is this an example of interpolation or extrapolation? Now let's look at our values. My x values over here in the table of values, my minimum is 4, and my maximum is 25, and 17 falls within it. So it's an example of interpolation. Now we could also use the line of best fit to predict our x value. So here it says, using your equation, predict the hours of TV watched, so that's my x, if the GPA is 3.5. So I'm going to do this work down here. Okay, so my y value is 3.5, and I want to know what's my x value. Okay, so we can use a series of inverse operations. And when we divide both sides by 0.05, we get x equals 6.8. Okay, so it says, using your equation, predict the hours of TV watched. So we're making a prediction. 6 hours of TV watched if the GPA is 3.5. So again, we're using our line of best fit to make predictions, either predicting x, which was our hours of TV, or our GPA. Okay. Now the next piece is interpreting, and this is really important. So we get our line of best fit. What does it mean? Okay. And so we're going to go back and use what we know about our slope. So it says, what does the slope represent? So as a reminder, slope is change in y over change in x. And we have our number, negative 0.05. So remember, that's my slope. And I'm going to make my denominator 1. The other really important piece about this is to look at our units. So for y, my units are GPA. And for x, we're talking about hours of TV. Okay, so what does the slope represent? Well, let's literally interpret this. So what it's saying is the GPA decreases, because it's negative, 0.05 per, which is the division part, per 1 hour of TV. Okay, again, let's break this down. In my numerator, the GPA decreases 0.05. That's why it's a negative 0.05 per comes from the division bar. Okay, and then we're going to look what's in our denominator, 1 hour of TV. Okay, and so we've interpreted the slope. Again, the slope represents that our GPA is decreasing 0.05 per every 1 hour of TV watched. Okay. What about the y-intercept? So the y-intercept, remember, so that's 3.84. So we're really talking about, what does 0.3.84 mean? Okay. Again, we're going to use our units. 0 is hours of TV watched. 3.84 is y, which is my GPA. So we're going to say the GPA of someone who watched 0 hours of TV. Okay, again, x is 0 hours of TV, and y is 3.84, which is the GPA. So you could also say, if you watch 0 hours of TV, you would predict a GPA of 3.84. Okay. Next, according to your model, could a student earn a 4.0 GPA? And I want you to think about that. What do you think?